See, the earlier chapter on statistical methods was telling us to do some calculations. But as we discussed, we have to slowly move towards making conclusions based on the calculation. So, the probability is something which expresses those calculations in terms of some percentage forms, right? Because probability is nothing but using the historical calculations or using some historical information I have, I'm making some kind of interpretation saying what is the chance of something to occur. Probability, or when we use the word probably, also we say the same. It's a chance of something occurring. So I have observed the historical data. In the historical data, probably there were 20 times when the returns were positive out of 50 days. So 40% was the number of days, 20 out of 50. 40% was the number of days where the returns are positive. Now, can I make some kind of an interpretation saying, even in the future, the chance of me becoming profitable is around 40%. So, that is where we are using the concepts of probability. Using historical information, deriving some kind of numbers for the future. So that is where we are calling, we are talking about probability, right? So most of the times we use it in the sense, okay, there is a 20% chance that the price will go up, 80% chance that the price will go down. For those kind of typical calculations is what we use the probability for. And where are those coming from? Probably from our historical observations. How do I say? There are different ways I can say. One, I can say based on the past. Yeah, in the past I have observed that 20% of the times it has gone up and 80% of the times it has gone down. So I may say that in the future also there is a 20% chance of up or down. Or someone else may say, no, past was completely different from the future. I feel there is a 50-50 chance for the future. So probability is nothing but a chance of something happening. And there are different ways in which you can define the probability, right? In simplistic sense, we are talking about the chance, which means we are moving away from the historical. In the earlier chapter, everything was on the historical data, calculations on the historical data. But now we are making a shift. Based on that information, can I use it for my future? The probability is talking about the chance of occurring in future, the chance of occurring or not occurring of some kind of an event. So that is where we talk about something called a random variable to start with, because anything where the outcome is uncertain, we call it as random, right? Tomorrow's stock price, up, down, it's uncertain. That I will call it as a random variable. And that random variable can have any number of outcomes. It can be, at least in this example, it is primarily like up or down or no change. But if I say my percentage change in price compared to today, tomorrow's percentage change in price compared to today, then it can take any value, 1%, 1.1%, 1.45%, minus 1.23%, whatever it is. These are the various values which a random variable can take. Random variable is something whose output I don't know. It comes through chance. Any outcome can come on a random basis or on a some specific. There is a randomness associated with the outcome. So you can think of anything to talk about the future. We can call it as a random variable, because we unless we are fully sure that this is what will occur, otherwise we are calling it as a random variable. The values which it can take are all called as the outcomes. Multiple, any value that it can take are called your outcomes. And sometimes what we might be interested in is some specific outcome or a series of outcomes which I want to track out of them, like positive, negative, up, down kind of up, down kind of outcome. I want to track only the up. What is the chance that something goes up? I want to track only the up part. So those are what I consider as my events. A group of probability, a group of outcomes which I would like to track out of the total set of outcomes, something which I would like to track for future purpose, for decision purpose. I'm calling them as the events. Now, within that event, so as I said, up, down, only if I want, they are the outcomes. If I want to track only the up, then up, the probability of going up is what is of my interest to me, but not the down. The chance of going up is more interest to me, not that of the down. So, in that, before we do the computation, we talk about couple of types of events. Mutually exclusive. When I say two events are mutually exclusive, if one occurs, the other cannot occur. If an up occurs on a particular day, down cannot occur, or vice versa. So those kind of events, we are calling them as mutually exclusive. And when I say exhaustive, at least one of them will definitely have to occur. Right? If I combine all those events, it should talk about the whole space. All outcomes should be included. If I say up and down, these two are mutually exclusive. And if I say these two are exhaustive, I don't say these two are exhaustive, because apart from up and down, no change also could be there. Right? If I combine up and down, all days of up, all days of down, it does not give me the total number of days. Probably there could be some days where there is no change. But if I combine all these three events, then I may say they are mutually exclusive. All three are mutually exclusive. If one occurs, the other don't occur. And all three are exhaustive also. This is something which we very much use in probability world. We are more interested in those kind of events which are mutually exclusive as well as collectively exhaustive. Collectively exhaustive, not in isolation. If I combine all the events, at least every outcome should be a part of at least one of that event. If I say, let's say throwing a dice, getting an even number is one event, getting an odd number is another event. Mutually exclusive, but even when I combine them, they are exhaustive also. I cannot get any other number apart from even and odd. But if I say event A is getting an even number, but event B is getting a number greater than 4, they are not mutually exclusive, because there, if one occurs, if an even number occurs, there is a good chance that it might be greater than 4 also. And coming to mutually exhaustive, if I combine these two events, it's not the whole space. 1 is not covered in any of them, 3 is not covered in any of them. So all possible outcomes are not covered in the combination of the two events. Then we don't call them as exhaustive, otherwise we are calling as exhaustive. The reason why we talk about is, if I have to make some prediction, if I have to make some conclusion about a particular stock price moving up or moving down, I need to know first of all how many outcomes are possible. Out of them, I want to see what is the one which I would like to track. Without knowing how many outcomes are possible, which is that exhaustive set of outcomes, without knowing how many outcomes are possible, I cannot track how many I want to track. Right? So that's the reason whenever we define the probability also, we say out of the total number of outcomes, how many are the ones which I am tracking? How many of them are favorable to me? So when I am looking at number of up days and down days, what is the probability that the price will go up tomorrow? If I am just observing the data and making a conclusion, the simple thing I am making is, okay, I have observed last 50 days of data. Out of that 20 days there is an up, 5 days there is no movement, 25 days there is a down. So if I want to use that data as an information for the future, I will say the probability of going up is nothing but 20 out of 50, saying 40% chance. That's the, so unless I know all the up, all the no change, all the down, I cannot make conclusion about the chance of something occurring in future. So we need a mutually exclusive and exhaustive set of events to define our probabilities in a very effective manner. So something, because we always talk about number of favorable to the total number, we always say that it lies between 0 and 1, and all probabilities put together for all the exhaustive events, it sums up to 1. Now, there are 3 ways people define probability. One, as I said, I observe the past data, just the example which I have given, 50 days, 20 days up. So observe the past data, and then based on the past data, take your percentages, which is nothing but a relative frequency in the stats which we have done. You take the relative frequency of each of the classes. Here the class is up, down, no change. For each of the classes, you find out your relative frequencies, and that's how you are finding out the probability. So you are not making any subjective guess or something. You are primarily looking at the past data and you are computing your probabilities, which is what is called as the empirical. Wherever you are using, wherever you are talking about number of favorable by number, total number, by observing your past data, that kind of probability which you are giving is called as an empirical probability, which if we are working with samples, most of the times we would be using the empirical probability model itself, right? Then if I compute the probability, computation of the probability is still the same, number of favorable events by the total number of outcomes, but the different ways. When I observe it from the past and I make some kind of a number between 0 and 1 and I calculate, we call it as empirical. Sometimes I won't do any calculations, I'll use a simple logic. Like there are 50 stocks on NSE. I want to pull up one stock at random. Any of the 50 can come out, right? Or what is the chance that I pick up an IT stock when I pull out a stock randomly from NSE, Nifty? There are 50 possible outcomes. Any out of the 50 I can pick. And out of that, let's say the IT stocks are some 7 or 8. 8, let's say. Now, 8 of them are favorable to me. So the probability of picking an IT stock from a Nifty 50 is nothing but 8 by 50. Here I did not observe any past data. I am using some common sense. I am using some logic. All of them have equal chance of being picked up. So 8 of them are more favorable, is what are of interest to me. There are 8 ways of picking up an IT stock. Probably if you look at it, there are 8 ways of picking one IT stock. So 8 out of the total number of outcomes is what we are calling as the probability. Here we are not using any observation of the past data. No one has picked up a stock at random, and we have not tabulated that, and we are not observing the past data and pulling up. We are using simple common sense. to attach a probability to it. That is what we call as a priori probability, where it's more of a general logic, formal reasoning kind of stuff. Number of ways in which the event can occur divided by the total number of outcomes. And finally, there is a third mechanism to probability called as your subjective, wherein no calculation, no reasoning. I'm using my past experience, my opinion in terms of saying, yeah, this is the chance. Probably if I ask an expert, what is the chance that the interest rates will go up in the next year? Right? He does not use his past data, or he may or may not use. But if he does not use the past data, if he uses just his common, if he is not even using a logic or a framework, but just out of his gut feel, saying, yeah, there is a 70% chance that the interest rates will go up next year. That is where we are calling as subjective probability. Sometimes we use that for our exam clearance also. Right? What is the chance that you clear a particular exam? Sometimes we use the word 50-50. Did we use any empirical data there? Which means if you had used the empirical data, probably out of 100 exams which you have written in your life, you should have failed in 50 of them. That is where you will use 50-50 as empirical, using the empirical approach. Did you use any logical reasoning? If you are using a logical reasoning, then probably there should be an equal chance of passing as well as failing, which also may or may not be supported for you in most of the cases. So you are using your gut feel, saying that the chances are 50-50. So some kind of a decision which you are taking based on your experience, based on your opinion, based on how you are perceiving, you are making a probability calculation. That is what we are calling as a subjective probability definition. So any of them, at the end, the use for me is they will help me in creating portfolios. They will help me in creating the return, in estimating the returns which I would be getting, in estimating the risk which I would be taking, because everything in finance is about future. There is nothing of the past when we use the word finance. I invest today. How much will I get in future? So everything we are talking about in the futuristic, in the uncertainistic kind of situations itself. Whatever is the space you are operating in, investment, risk management, whatever is the space we are talking of, I am investing, I am putting my money something today. How much will I get in future, which is nothing assured. So because nothing is assured, we have to look at the probabilities of it getting achieved. So that is where this entire world of stats and probability is getting linked into the finance world, because everything is to do with the uncertainty space itself. So the same probability sometimes people talk of in terms of odds, the betting kind of scenarios, right? Probably when I say a probability is 1 by 4, sometimes we express this in terms of the odds for as well as odds against that particular event, which is nothing but, so out of 4 chances, 4 outcomes, 1 is favorable, right? That is what is the definition here. Out of the 4 outcomes, 1 is favorable, which means 3 are unfavorable. So the odds per will simply go as 1:3. The favorable is to unfavorable. Odds against is nothing but unfavorable is to favorable. So sometimes from our exam standpoint, you may give the probability and ask us to find out the odds, or sometimes he may give the odds per or odds against and ask us to find out the probability. So if he is giving the probability or odds per is 1:4, I can very well say that the probability of occurrence of that is 1 by 5, and the probability of non-occurrence of that is 4 by 5. This is one more way to define probability. And sometimes people don't define something in the terms of probability. If we see the betting meters and all in various places, people don't talk in terms of probability. People talk in terms of odds. The most of the betting games